Hello students, today's agenda is to check homework. We'll be learning exponential growth and decay, and you can do page 10. Today students will be able to graph exponential growth and decay functions. And so we are going to be able to identify before we even graph whether our function will be an exponential growth or exponential decay. The function will be written in this form, which is f of x equals b to the x power, and this b is the number that will change. If b is a number that is greater than 1, then it's an exponential growth. If b is greater than 0 but less than 1, meaning that it's a fraction, a proper fraction, then it's an exponential decay. So if it says y equals 2 to the x power, and this y could either be y or f of x. For x, we're going to choose values 0, -1, -2 going up, and then going on the other direction is +1 and +2. Okay, so let's find the values. What we're doing is to find the value of y when x is -2, we're going to put y is equals to 2 to the, instead of x, we put the value of x, which is -2. Whenever we have a negative exponent, we send it to the denominator and put in 1 on the top in the numerator. And so, al calabozo, let's send it to the dungeon to make it positive. Okay, so it's 2 to the second power. And so that's 1 over 2 to the second power is 4. So when x is -2, this will be 1/4. For the next one, y is equals to 2 to the power of x, which is -1. We substitute, send it to the dungeon. So 1 over, this goes to the denominator, 2 to the first power, which is, we don't need to put the 1 as an exponent, so it's just 1/2 or 0.5. For the next one, x to the 0 power. It's, remember that anything raised to the 0 power is 1, so we just place that in there. For the next one, the x is 1, so it's going to be 2 to the first power, which is just 2. Any number raised to the chiquitito is going to be the same base, okay, the same number. Y equals 2 to the x power, the x is a 2. 2 to the second power is 4. And so when x is 2, y is 4. I'll cover this for now so that we can do our graph. So when x is -2, we go -1, -2, +1/4 is right there. 1/4. That means that we cut the first number because this is 1 for y, 2, 3, 4. So the 1, we divide it by in fourths or 4 pieces and then just get one of those. For -1 is 1/2. For 0, the y value is 1. For x1, y is 2, 1, 2. And for 2, 1, 2, the y value is 4. Beforehand, we knew that this is a whole number, is bigger than 1, so that's exponential growth. And you see that it's growing. From left to right, it grows. So that's where my graph would go. In that direction, it goes up, up, up to the sky. And then on this direction, it's going to go a smaller fraction, but then it will never touch 0. So infinitely on that direction without touching the x-axis. That means that the asymptote, meaning the line that it will never touch, is going to be at 0. We look at the domain. The domain, well, if we go all the way to the left, that's pointing to the left. That means that it will keep going. And the values on x on that direction, even though it's slowly moving towards the right side, it will continue to go. So that means that the domain, meaning the x values, are all real numbers. For the range, that's the values of y. Since this graph, it has an asymptote, meaning that it doesn't touch that 0, is going to be greater than that. We don't know how close it will get, but it never touches 0. So for the range, it means that it's going to be y is greater, not equal because it doesn't touch 0, greater than 0. Okay, for the next one, we're going to choose the same values, 0, -1, -2, +1, +2. Since this, which is the value of b, is less than 1 but greater than 0, it means that it's going to be an exponential decay. And so we're going to do y equals 1/3 to the, what's the value of x? -2. We learned that when we have a fraction with a negative, remember that then this means, and I'll do the first one the long way, but then I'll just do the trick skipping this step. It means that 1, there's a chiquitito, right? So you're multiplying by each one is 1 to the -2nd power and 3 to the negative, because -2 times 1 is -2. But if we have negative exponents, then this goes to the denominator and this goes to the numerator to make the exponent positive. So it's going to be 3 to the 2nd power, or 3 squared, over 1 squared. So in the next ones, I'm just going to put the 3 on top with that, but positive, with that exponent, but positive. And the 1 goes down with that exponent, but now positive instead of negative. Okay, skipping this step. Okay, so 3 to the 2nd power means 3 times 3, which is 9. 1 to the 2nd power, or 1 squared, is 1 times 1, which is 1. And 9 divided by 1 is 9. So when x is -2, the value of y is 9. For the next one, I'm going to go a little faster. So it's 1/3 to the -1 power. I send the 1 down, I send the 3 up. The exponent is -1, so it goes positive, positive. The 1 as exponent, we don't need to put it. 1 we don't use as an exponent. 3 to the 1 power is 3, 1 to the 1 power is 1, and 3 divided by 1 is 3. Okay, so y is 3. For 0, remember that anything, fractions or no fractions raised to the 0 power, is always, the answer is always 1. Okay, the next one, 1/3 to the power 1, it's just the base, is the same value, so the answer is 1/3. Why? Because 1 to the 1 power is 1, and 3 to the 1st power is 3. And the last one, 1/3 to the 2nd power, it just means 1 to the 2nd power, 3 to the 2nd power. Some people, 3 to the 2nd power. Some people ask me why in here we don't send this to the numerator and this to the denominator. We do that only when the exponent is negative, okay? 1 to the 2nd power is 1. We also read it 1 squared. And 3 squared is 9, so 1/9. For our graph, we go -2 on x, 9 on y, so 2, 4, 6, 8, 9 right here. -1, 3, -1, 3 is right here. 0, 1, 0, 1 is right here. 1, 1/3, 1, 1/3 means right there. It means cut it in 3 parts and get one of those parts. 1/9, whew, cut this in 9 parts and then get 1 right there. So our graph is going to go something like that. Remember, it never crosses the asymptote. The asymptote in here is again 0. And so that's where we stop, or a little before that, because it never touches that. Okay, it also goes on and on that direction. For the domain, again, remember, whenever you have arrows, it means that, notice how it's going a little to the left, fast, like not super fast, but it's moving a little to the left each each movement, okay? A little to the left. So the domain, that means that is going to be all real numbers. For the range, which are the y values, well, it never goes below the value of 0. It just goes above that. And so we say that y is greater than 0. For number 3, we have y equals 4/3 to the x power. This, if we divide 4 by 3, the answer will be 1.3333. 4 divided by 3, 1.3333 forever. That means that because it's bigger than 1, this is a growth, exponential growth. And you can see that before we even graph it. Not a decay, but growth. And so for the values, we do y equals 4/3 to the negative second power, right? We just substitute the x. This, because it's negative, goes to the denominator, and the denominator goes to the numerator to make the exponent positive. So it's going to be 3 to the second power, or 3 squared, over 4 squared. 3 squared means 3 times 3. And I'm going to show you in the calculator. What you do is put the base. This is the power button. It can be this. It can be x to the y power, or it can be x to the, and then there is a little square. So any of these keys will mean power, okay? In this calculator, it's this one right here. And then we put the second power equals. So this is tiny, that's why I'm not using the calculator but if you have bigger exponents, then you should. 3 squared is 9. 4 squared means 16. And then we're going to divide 9 by 16. Let's round it to the 10, so it will be 0.6. The 6 gives 1 to the 5, okay? So the second number, if it's 5 or more, it will give 1 to the previous one. If this is 4, 3, 2, 1, or 0, then this one will stay as 5. For the next one, it's going to be y equals 4/3 to the negative 1 power, which is equals to, again, we send the denominator to the numerator and the numerator to the denominator to make the negative 1 positive. So it's 3 to the 1 power over 4 to the 1 power. Remember that power or exponent 1, we don't need to put it. And 3 divided by 4 is one of those that I asked you to memorize. 3/4 is the same as 0.75. I forgot to. And round it, you just add one more. Remember, if this is 5, 6, 7, 8, 9, then this goes 1 up, meaning that it becomes 8. Or 0.8. For the next one, 4/3 to the 0 power. Anything to the power of 0 is 1. For the next one, 4/3 to the power of 1. Anything to the power of 1 is just equal to that same number. So 4 divided by 3, but you cannot actually use your calculator if you're not sure, is 1.3333 forever. So it's 1.3. And the last one, y is equals to 4/3 to the second power. Remember that it's positive, so all you have to do is basically multiply el chiquitito, the teeny tiny one in there. So it's 4 to the 1 times 2 is 2. 3 to the 2 times 1 is 2. 4 squared is 16. 3 squared is 9. And when we divide 16 by 9, the answer is, the second 7 gives 1 to the first 7, so it's 1.8. And you will notice that the points are very close to each other, so I'm going to give one more point in there, but in a minute. So when x is -2, then y is 0.6, a little bit more than half. When x is -1, y is 0.8. It means cut it in 10 pieces and then you get 8 of those. When x is 0, y is 1. When x is 1, y is 1.3. 1.3. It means 1 and then 1/3 of the next one. When x is 2, is 1.8. So if you notice, it's very hard to see a graph like this. So I'm going to choose one more point, maybe a 5. I'll move this to the side. And then I do y is equals to 4/3 to the 5th power. It means 4 to the 5th over 3 to the 5th. 4 power button 5 equals, that's 1024 divided by 3 power button 5 equals 243. And then we divide that value, those values. So 1024 divided by 243 gives me 4.2. Because the second number is less than 4 or less, if this is 1, then it doesn't give anything to the 2. So it's 4.2. Okay, so 4.2 when x is 5. Back to the graph is 1, 2, 3, 4, 5, and then 1, 2, 3, 4, and a little bit more. So right there. So this is just to help me guide my graph because I didn't have enough. So in here, on this direction, is also very close to 0, but it never touches 0. That's the asymptote, okay? The domain, it goes infinitely to the left, infinitely to the right. That's all real numbers. For the range, it doesn't go below 0. It's only above 0, and it keeps going because it has the arrow. So that means that y is greater than 0. With this, we end our lesson. If you can please support our channel by giving us a thumbs up, subscribing around here. This is the link to the entire unit, and here you will find the next lesson. Now you're able to do page 10 and have fun.